Your brain is not a storage device. That mental model, the idea that learning is just filling up space with information, is actually holding millions of people back from getting better at the things they care about. Because the real process is so much more interesting, and the implications completely change how you should be spending your practice time. When you start learning something new, a language, an instrument, a sport, a coding language, anything, your brain kicks off a biological process called neuroplasticity. And the word plasticity is key here. It means your brain tissue is literally reshaping itself in response to what you're doing. Here's what that looks like at the cellular level. Every time you practice a skill, certain neurons, those are the cells that carry signals through your brain, fire in a specific sequence. Think of it like a path through a dense forest. The first time you walk that path, it's overgrown. You're pushing through brush. The signal travels slowly, imprecisely. That's why the first time you try to play a chord on a guitar or speak a sentence in a new language, it feels clunky and effortful. Your neurons are essentially hacking through that forest for the first time. But here's where it gets fascinating. Every time those neurons fire together, a few things happen physically. The synaptic connections between them get stronger. The gaps between neurons, called synapses, literally change shape to become more efficient at passing signals. More receptors open up. The signal moves faster and with less noise. And then there's myelin. Myelin is a fatty white substance that wraps around nerve fibers, like insulation around an electrical wire. The more a neural pathway is used correctly, the more myelin wraps around it. And the more myelin there is, the faster and cleaner that signal travels. We're talking up to 100 times faster signal transmission on a heavily myelinated pathway versus a bare one. So when you see someone who's mastered a skill, a concert pianist whose fingers move without conscious thought, a surgeon whose hands know exactly what to do, what you're actually watching is the physical result of thickened myelin sheaths, dense synaptic connections, and entire cortical regions that have literally grown to dedicate more gray matter to that skill. Brain scans prove this. Studies on London taxi drivers showed that the hippocampus, the region involved in navigation, was measurably larger than average. Musicians showed denser gray matter in motor and auditory cortices. Bilingual speakers have structural differences in language regions. This isn't metaphorical, it's anatomical. So you'd think, more repetitions equals more myelin equals faster skill acquisition, right? Not exactly. And this is where a lot of dedicated, hardworking people accidentally sabotage themselves. Research from neuroscientists like Dr. Andrew Huberman at Stanford and work building on Daniel Coyle's synthesis of myelin research in the talent code points to something crucial. Your brain consolidates new neural pathways not during practice, but after it. During practice, you're generating the signal, you're firing the neurons. But the actual structural reinforcement, the myelin wrapping, the synaptic strengthening, the gray matter density increases, that mostly happens during rest, specifically during sleep. This is not a minor footnote, this is the whole game. Think of it this way. Practice is like laying out the blueprint. Sleep is when the construction crew actually shows up and builds the thing. If you skip the rest, or if you cram so many repetitions into one session that your brain never gets proper consolidation time, you're handing blueprints to a crew that never gets to do their job. Studies have shown that people who sleep between practice sessions learn significantly faster than those who practice the same total number of hours but sleep less or practice in longer, compressed sessions. In one particularly striking study on motor skill learning, participants who slept between their practice sessions showed 20% greater performance improvement compared to those who stayed awake and practiced more. 20%, just from sleeping between sessions. But here's where it gets even more nuanced, because it's not just about sleep, it's about the spacing of your practice sessions altogether. There's a principle in cognitive neuroscience called the spacing effect, and it's one of the most replicated findings in the entire field. The idea is simple. Spreading practice out over time produces far stronger, more durable neural encoding than cramming the same amount of practice into one session. But why does spacing work at a biological level? This is the part most learning articles skip over. When you return to a skill after a gap, Even just a few hours, your neural pathways for that skill have partially faded. They're not gone, but they've weakened slightly. When you fire those neurons again, your brain essentially has to re-recruit the pathway. And here's the key. That act of re-recruitment, of struggling slightly to re-access the skill, triggers a stronger myelination response than practicing on something that's still hot. Neuroscientists call this desirable difficulty. The slight struggle of reactivation tells your brain this pathway is being accessed repeatedly across time. It must be important. Build it stronger. Whereas back-to-back repetitions in one session, your brain treats that as a single prolonged event. You get some reinforcement, yes, but you don't get the same growth signal as spaced practice provides. This is also why interleaving works, alternating between different skills or sub-skills rather than drilling one thing to death. Interleaving introduces productive interruption. It forces more reactivation events. More reactivation events mean more myelination triggers. More myelination means faster, more automatic skill execution. The practical implication of this is almost counterintuitive. Shorter, more frequent practice sessions almost always outperform longer, less frequent ones, even when total practice time is identical. 2 30-minute sessions across 2 days will build a stronger neural structure than one 60-minute session in a single sitting. 3 20-minute sessions will beat one 60-minute session even more convincingly. And the gap between sessions, where you sleep, rest, and let consolidation happen, is not wasted time. It's active construction time. Now let's go back to something I teased earlier. What happens when you stop practicing? This is called synaptic pruning, and it's just as real as synaptic strengthening. Neural pathways that go unused get progressively dismantled. The brain is constantly doing a kind of biological cost-benefit analysis. If a pathway isn't being used, the resources maintaining it get redirected elsewhere. The myelin can thin. The synaptic receptors retract. The gray matter density in that region can actually decrease. This sounds alarming, but there's an upside. The process is much slower than skill acquisition. And for deeply established skills, it's surprisingly reversible. This is the science behind muscle memory, or more accurately, motor memory. A skill you learned years ago and haven't practiced can often be reacquired much faster the second time, because the foundational neural architecture, while faded, never fully disappeared. You've probably experienced this. Picking up an instrument you played years ago, getting back on a bike, speaking a language you studied in school. There's a reactivation speed that surprises you. That's your brain's existing architecture firing back up. But here's the actionable takeaway. Don't let skills go fully dormant. Maintenance practice, even brief, infrequent sessions, dramatically slows pruning. Touching a skill once a week is often enough to preserve the structural gains you fought hard to build. You don't need to be in active learning mode to protect what you've built. You just need to send the signal often enough that your brain doesn't start reclaiming those neural resources. So what does this all actually look like in practice? First, prioritize sleep immediately after learning. If you're trying to acquire a skill, the sleep you get that night is not separate from the practice. It's the second half of it. Protect it. Don't practice something new and then immediately stay up late. You're essentially leaving money on the table. Second, keep sessions short and spaced. Aim for 20 to 45-minute focused practice sessions rather than 2-hour marathons. Let at least several hours pass between sessions when possible, and ideally, a full sleep cycle. Your brain does more with that structure than it does with brute force duration. Third, don't avoid the difficulty. The slight struggle of spacing, the feeling that you've half forgotten something and are retrieving it, is a feature, not a bug. Resist the urge to immediately drill something you just got right. Walk away. Come back. Let the reactivation happen. Fourth, use interleaving deliberately. Instead of drilling skill A for an hour, try practicing A for 15 minutes, shifting to B for 15 minutes, then returning to A. The interruption feels less efficient in the moment. Your performance will be slightly messier during the session, but the neural gains will be measurably greater. Fifth, maintenance beats relearning. If you have a skill you care about preserving, even 10 to 15 minutes a week can slow pruning dramatically. You're not building, you're just keeping the lights on. And it works. Here's the bottom line. Your brain is an active, living structure that physically reorganizes itself around what you do, and crucially, around when and how you do it. The old model of more hours equals more skill is incomplete at best and counterproductive at worst. What your brain actually responds to is spaced, intentional practice followed by proper rest. The kind of rhythm that triggers myelination, synaptic reinforcement, and lasting structural change. Effort matters. Hours matter. But the architecture of your time matters more. And honestly, I find that kind of liberating. Because it means the person who practices smarter, who spaces it out, who sleeps on it, who lets the biology work, will outpace the person who just grinds harder. You don't have to suffer more. You have to structure better. If anything in this video landed for you, whether it's the myelin piece, the spacing effect, or just the realization that your rest is part of your practice, I'd genuinely love to hear which part. Drop it in the comments below. I read them, and it actually shapes what I make next. If you found this useful, hit the like button. It really does help more people find this kind of content. And if you want more videos on how learning, memory, and brain science actually work at a practical level, subscribe so you don't miss the next one. I put new stuff out regularly, and this kind of topic is exactly what this channel is built for. Thanks for watching. I'll see you in the next one.